Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining the process of database design. Right? So in SDLC, if you want to develop a software, you need to design, right? You need to do the design, right? In the same way, to design the database also, I am going to do the design. In this video, I am explaining the design process. If you are not subscribed to my channel, please subscribe to my channel, and please don't forget to like the video, and please don't forget to share the video with your friends. To get the notification of my new videos, please click the bell icon. So let me begin the explanation of the process of database design. Yes, you can see here mini word. Mini word means whatever the application or whatever the database I am going to develop, it's purely related to the real world, right? For example, if I am going to develop a bank database, again bank is a real word thing. If I am going to develop a university database, again university is a real world thing. Whatever the database we are going to design, the entire database, whatever the database you take, it will be related to the world, right? Because users going to use our database, right? And that users are present in the real world, that's why, right? So don't get confused here. A mini word means so real world, whatever the database I am going to design, the database is purely related to the world. Bank, university, railway, each and everything will be present in the world, right? Now what is the first step? I want to, for example, assume that I want to design the bank database. So to design the bank database, what I have to do? For example, to design any software, again database is also software, right? To design that, what is the first step means? I have to do the requirement collection and analysis. Very simple. So if I am developing a bank database, I will go to the customer, I will ask for his requirement. For example, customer can say, I need a username and password feature, that is authentication feature. I need a feature to create the account, I need a feature to delete the account, I need a feature to add the customers, I need a feature to delete the customers. So the requirement can be thousands of requirements can be right there. So I have to collect that requirements before designing the database, right? That is the first step, you can see there. So this requirement collection purpose is to produce a description of user requirements. I need to collect what users want from our database, right? That is the first step. And I have to do the analysis also. Analysis means what? I have to do analysis means I have to do the feasibility study. I have to check whether all these requirements can be implemented or not. Some requirements can't be implemented practically. Theoretically, the customer can tell you have to implement this, but practically it may be impossible. So I have to do the proper analysis. I have to select the most important requirements and I have to proceed further. And for example, in a requirements, there will be two types, functional and non-functional requirements. Functional requirement means, for example, in a bank database, create account is a functional requirement. Your software should function like this. Delete account is a functional requirement. Your software should work like this. But non-functional requirements means what? The non-functional requirements means your software should work efficiently. Efficiently means what? That is non-functional requirement. Efficiency is a non-functional requirement. Yes, your software should create an account. Yes, create an account within 5 seconds. So you can see there. Yes, creating the account, that is a functional requirement. Within 5 seconds is a non-functional requirement. You are putting a condition, you are putting a constraint. That conditions or constraints are nothing but non-functional requirement. So along with the functional requirement, non-functional requirements also need to be fulfilled for the success of your database. You can see there in the diagram, functional requirement, functional analysis also done, right, along with the data requirements. So next step is what? Conceptual design. Conceptual design means You are to convert your requirements into diagram format. You have to convert your requirements into diagram format. Here, while designing the database, for example, I have to convert my requirements into entities. I have to convert I have to include attributes for that entities. I have to establish the relationship between that entities. For example, I have to construct the entity relationship model. I have to construct the entity relationship model. Conceptual design means in a SDLC, you are going to convert your requirements into activity diagram, sequence diagram, flow chart, data flow diagrams, like that, right? In the same way, I have to design the database. I have to convert my requirements into ER diagram. Here in my requirements, I have to select the entity, I have to select the attributes, and I have to select the relationship between the entities. For example, see, this is the entity diagram of a company database, right? So this is the example. See here, for example, entity means what? Entity is a real world object. I'm developing a company database. Here, what are the real world object? Employee is a real world object, department is a real world object, project is a real world object. You can see there. So what I did, I'm converting my requirement into diagram format. So in my requirement document, I have to check for the nouns. Nouns can be my entities. Hope you are understanding. So I referred my requirement document, I selected these entities. Now after the entities, I have to select the attributes. Attributes are nothing but it is going to describe your entity. For example, employee can be described by first name, birth date, name, address, salary, sex. See, I am describing my entity employee using the attributes address, salary, name, birth date, etc. And also, two entities can be related to each other. You can see employee works for the department. Department and employee are related to each other. How? Employee works for department. So I am finding out the relationship between two entities also. Getting, guys? So this is the simple ER diagram. In the upcoming videos, I'm going to explain these notations. Don't worry about these notations, all those things. We'll explain different ER diagrams in the upcoming videos. Right? So far you understood that. Here, what is the second step? I have to convert my requirements into ER diagrams like this. Now we can ask question, why? Why means our requirements will be in the text format. But if you see the text and if you see this diagram, which you will understand the diagrams in a more better way than your requirements that is in the text, right? That's why I have to convert my requirements into conceptual diagram, that is ER diagram. Conceptual means your ER diagram. Conceptual, it is not a real database, but it's the diagram of your database, right? Next, once our design is ready, once our diagram is ready, I have to implement it. Implement it means I have to write the program, I have to write the source code. I have to write the source code to create our database. Very simple. See, so conceptual design is ready. Once the conceptual design is ready, I have to write the source code. That mapping should be done. Mapping means logical design, that is mapping. Here this employee, these entities are there, right? That the entities need to be converted into source code format, right? That is mapping. Data model mapping. You are going to take your conceptual schema and you are going to implement and you are going to write the source code to create the database. You can see there. So here these are up to designing, these are DBMS independent. Later, whatever the program you are going to write, that are DBMS specific. For example, if it's a bank database, up to design, it will be different thing. But once you are going to write a code for bank database, you will write a different code. For university database, you will write a different code. For company database, you will write a different code. That's why the application program design, the implementation of this, right, will be a DBMS specific. Hope you are understanding, guys. Please don't get confused. If you have any doubts, please post your doubts in the comment section. So once the implementation is done, now you have to design. Source code is ready, but after the source code is ready, you have to decide upon the internal storage structures. For example, you are writing a program. Once your application program is done, once your database is ready, you have to decide in what format I have to store my data. For example, if it's a relational database, you will store the data in the table format. If it's a hierarchical database, you will store the data in the tree structure. Now we have to decide, yes, my application program is ready, my database is ready, I implemented it, but in what way I have to store it? What is the internal schema? What is the storage details? What it will be like? You have to decide that. If it's a relational database, it should be in a table format. So if it's object oriented database, it will be in the different format, right? Like that. So physical design means here you have to decide how you are going to store your data in an internal storage, and how you are going to implement your paths, how you are going to implement your addressing. Those things will be taken care by physical design. Implementation, yes, your database is ready, your application program is ready, but you have to design internally. You have to take internal design. You have to do it in a physical design phase, right? Getting, guys? So hope you understood the concepts. I tried to be very simple. If you have any doubts, please post your doubts in the comment section, right? Thank you for watching the video.